all this stuff I will share, and all this code stuff is inside the Git repository. I will give you the name of this repository after the talk or during the last slides, and then you can follow all this stuff up again. Okay, someone here who's not working with Java, but you can read Java? Okay. I had in one talk some guy about Java, and he was saying, oh, PHP, can you please translate? No. I can only Java, nothing more. So, are you ready? Yes. Yeah, I can't see something, so you have to say it to me. Okay, let's introduce myself. I'm Sven Ruppert, and I'm living in Munich. It's in south of Germany. And I'm working for a company with around 4,000 people, and I have a very, very cool job there because my job is learning. Learning, 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 and learning. That's the whole thing I have to do, and then try to make the team I'm responsible for better. This is quite cool because this will give me the chance to go to conferences and read books, write books, and all this stuff. But this is not what I've done the whole time. So I'm writing Java, or I'm earning my money with Java since 1996. It's Java 1.1 or 1.2, and I was working in different areas, companies, Europe, Asia, somewhere, but there was something that will come with me the whole time, and this is old, huge projects. So, any one of you is working only on greenfield projects, running 6 months and then it's done? No. Old projects, more than 1 year old? 2 years? 3 years? Java 1.4? Oh my God, automobile industry or military? Congratulations. Everything I will show here, you can use, no, not everything, but the most of it you can use with 1.4. Okay, so, and there was one thing in all this huge in old projects that they start very tiny and then they grow and grow and grow, and I think everybody of you know this, that you will start with a design pattern and then everything will explode. The next module, you have no idea what to do to get rid of all these dependencies and all this stuff. That's one thing. And the other thing is that during the 90s, a lot of people really liked model-driven development, and this leads to source code generation. Anyone here who's using source code generation or pattern-based generation stuff? Oh, okay. And you? Same? Okay. Yeah. But mostly service will have one. Okay, service maybe if you're hiding technical stuff, but mostly if you're generating stuff, you will generate a lot of boilerplate code. And then there was one project, hundreds of thousands of lines of code, and you could replace it with one proxy. So after this, we threw away a few lines of code, and then the IDE was working again quite fast. So this is why proxies are, from my point of view, very important. So what proxies are? Right? No, there's a free seat. Feel free. So what we are using, or why I'm talking about proxies. Proxies we can use to code generic parts of your application, and everything I will show you here you can do with core JDK. So no additional library or whatever you need. So you have no legal stuff, you have no rules, no versions from other tools that you have to think about and analyze and all this stuff. So proxies are very good to write generic part of your application, and it's quite cool, and it's basic stuff for dependency injection or something like this, so to decouple parts of your project. And the other thing is you can hide a lot of technical stuff so that you don't have to write again and again and again the same thing. And this mostly makes some parts of the project quite easy. So if you have not so well-educated developer, they can't do so much mistakes. And this is quite often saving time and money. So, the most important thing is, if you're working with proxies, writing proxies is not so easy. Okay, but if the result will be that the usage will be easy, then you have reached a huge goal. And for example, if you have a class and you want to create a proxy, from the developer point of view, it would be nice if you have something like a builder, and then you can add additional stuff. Something like, okay, this must be with logging. I want to add metrics with, for example, how often, how fast something is executed, and maybe some security rules, business rules, whatever, a lot of them, and then please be ready and build my proxy. So if you have something like this in the end, and I will show you how you can write codes that this will be the user interface to write this, then this is really easy to use. And this will save some time. The other thing is, proxies are the basic stuff for dependency injection. This means if you're using standard dependency injection mechanisms like well container, Goose, Dagger, Boon, whatever, or if you have to write your own dependency injection framework because you have some needs or whatever, it would be quite nice if you could write something like this. So please inject something, but it must be a proxy, and then decide what kind of proxy. If it is a virtual proxy, yes, no. If you want to have matrix, true, yes, no, something like this. So you can decide what you want to have, but it's somewhere else. Any questions until now? Yes?
Does it have to be an interface? What happens when JK dynamic proxy can't do classes?
Yes, this I will come through. But one thing you learned at the university is use interfaces. Now I will show you why it could be useful. No. So this could be, if you're using dynamic proxies, I will show it to you, then you have to use interfaces, but if you're working on your own dependency injection framework, you can get rid of this if you want, but I would recommend use it. Use interface. It's not so bad as it sounds like. Okay. So this is the motivation, but how to come through? The most of you knows an adapter. I'm talking about an adapter with delegator. So this means quite a lot of people come through and say proxy identity, proxy, or what's the difference between a proxy and an adapter? So to stop the discussion at this point in the beginning, I would show, okay, there is an adapter, but there are some main differences from an adapter and a proxy. And this means that an adapter you can use if you have a method with a signature and that's not convenient or not good, fulfills not your rules you need, and then you can write an adapter. An adapter with delegator. This means you have a legacy worker and, for example, this write the strings method. Please don't ask if this is useful. It's only an example. And then you create a worker adapter, for example, and then you can change, for example, the method name, or you can change from an array to a list of string. But this adapter is not inside the inheritance, because if it is inside the inheritance, you have both method signatures, and with an adapter you only want to have the new one, so that you're using the new one. And this is one of the biggest difference through a proxy. A proxy is inside in your inheritance, because this is a replacement. An adapter is an additional thing. So this means this is the old one you don't want to use, this is a new one you want to have, then you have only inside the transformation code, and the most important thing is you are creating the instance of the delegator mostly at the same time you're creating the adapter. And then I will show you a proxy will have a different feeling at this point. By the way, can you read this source code? Okay, good. Anyone here who's not able to see the difference between green and red? Nobody?
I want to say yeah.
You can see the difference between green and red, good, but some people not. So I wasn't thinking about during the time I was creating the slides. So sorry for this. So, but, well, if you're using adapter and a proxy, you will see in the same way, you will create an instance and then only use it. So the same thing we want to have with proxies. So, okay. If you're using adapter, you don't need to know the legacy worker. It's hidden for you, and this is one of the points you're using it. And you have no inheritance between the legacy worker and the adapter. That means all code with instance of and all this stuff will break. So you have to change mostly a lot of stuff. So, and please use an adapter like an adapter, only transformation of the signature. That's all. Okay, same creation time between delegator and adapter. We had this. So, we need a few steps to come to a proxy. By the way, who knows the proxy pattern from the gang of 4? Okay, so if I'm too fast for all the other one, let me know. Okay, a proxy, if we want to write a proxy, we need to know the legacy worker because we have a replacement. And we have inheritance between legacy worker and adapter. This means I can extend the interface, but it makes no sense because from outside a proxy and the original must be the same. So extending the interface is mostly something you only use if you want to do some additional hidden stuff, but try to avoid it. Okay. And please don't use proxies like an adapter. If you have an adapter, call it adapter and use it inside your proxy. So, time for code, oh? I think so. Okay. Let's write the easiest version of a proxy with delegator. This means we have an interface. For this, it's called service and only a method called work. Then I have a standard implementation. This I need because the proxy is delegating through something, so I have an implementation at this point. And then I'm writing the first and easiest version of a proxy. Completely useless. Well, so I'm only delegating. This means I can replace at every attribute where I'm using service, I can write new service proxy or I can write new service impl. So there's no difference, and the behavior in this case is completely the same. So we have different proxy groups. So proxy itself is only a replacement, so something like an embassy in a different country. So if you're going through the embassy, then you are more or less inside another country. And the same is for the proxy. It's something that you can contact, but something on another place or another meaning is done. So we have some groups, some main groups of proxies. One of the easy to understand is the security proxy. The security proxy is quite easy. If we see here, we have the original proxy, but what could we change now? The goal of a security proxy will be execute only if it is allowed. So whatever it means. If we want to do this, we have to make some decisions. I have a very easy decision done. So I only says, if it is not allowed, do nothing, return null. So you have to find something more useful in your case, but it's only to show what's going on at a security proxy. This means you have some point to check a rule, and then you have, oops, security. It's the first time that I'm using Keynote, so if I'm jumping between slides, please. Yeah, well. And for me, it's easy to use because everything that is with colors, for me, too complicated. So, yeah, this is the point. So you have to decide if it is allowed, yes, no. And this could be more complex, and then you have to ask, for example, who's setting code or who's setting whatever you want to compare and all this stuff. But the main thing is the security proxy will execute a rule and then decide yes or no. That's the easiest version. So the next big group is remote proxy. Remote proxy is something that you want to execute in different JVM, for example. Yeah, something outside of my process. It's not only limited inside your JVM. So with core JDK, you can write it quite easy. From outside, you want to have a remote proxy, and you want to say, proxy, do your work. So this one. But to reach this goal, we need some work. This work is mostly technical stuff. There's a request coming in, going through the proxy. This proxy will have this interface, so it's the same for you. Then some remote communication could be done a few times, not only one time. This is more or less bidirectional because you are sending something, you are getting something. Then it's going through the same interface because on the server side you want to implement the same interface. You have this remote service and then something is going on. This is a basic thing you have to have in mind with this. So you have a client side, you have a server side, and then you have this interface. If you're writing this interface, this is more or less technical stuff. So you see you have an interface service and the same signature, but you have this add web service, add soap binding and all this stuff. So this is technical stuff depending on the technology you're using for the remote communication. It's not part of the pattern itself. But if you're combining later proxies, I will show how, you have to keep in mind that sometimes you have this problem that you have more or less the same interface, but sometimes with technical information, sometimes without technical information. So it makes no sense, for example, to put everywhere this add web service in the main interface, because maybe you want to write sometimes a SOAP remote service. So you have to think about how you can do it. So going back through this, we have this remote service, how to write. This one, it's more or less the same like the plain implementation, but only with a few annotations. This is if you're writing a remote service or a remote proxy with core JDK. It's part of it. I can write this SOAP services. So next part would be how to publish this, because you have between two JVMs. This is quite easy. You have additionally this is technical stuff. And the only thing you have to put in is a service input. All the other stuff is well documented, how to publish an endpoint. That's it. But it's not part of the pattern, it's technical stuff. So remote proxies are more or less always mixed up with a lot of technical stuff, and this you have to hide to get rid of it. It's not part of the pattern. Okay, then we have the client side. The client side itself is, again, a lot of technical stuff, depending on the technology, but you're working with the same interface here. So, and after this, you can say, do your work. So, if you're writing remote proxies, you have to decide what kind of communication technology you want to use, but the main thing is you have two processors and they're communicating, and from this point, if you're using this one, you only have to say, okay, new service remote proxy, and then deal like a local instance with it. Okay, so we have remote communication with remote proxies. We have mostly a lot of technical based work, and the main goal is that the developer will not see this technology stuff. That's all. Okay, remote proxy, it's done. Now we are coming to the very important group. If you have the security and the remote proxy, we have the virtual proxy, and with this you can do a lot of stuff. Going back to the main implementation of the proxy, we want to change it now to a virtual proxy. A virtual proxy will create the delegator later. This means you have something you can work on, but only if you invoke the first method, the instance will be created. So you have the possibility to write a lightweight proxy, and if the heavyweight implementation will be created only if you are invoking one method. If never, you're never using these resources. That's a Excuse me?
Lazy init.
Yeah, it's a lazy init, but this lazy init is not so easy. Because lazy init leads to a lot of different problems, but give a lot of chances. The easiest one you can use is this one. So you say my delegator is null, and if the first time work will be invoked, then I will check service equals null. Okay, created. What's the biggest problem here? Ah, okay, there's something. Huh? This one is null. You have your normal implementation, and then, yeah, it's not thread safe. That's the biggest problem. Well, what I've done? Yeah, that's the problem. I don't know Keynote so good. I have to check it. Okay, this one. So it's null, and there's a main implementation. Okay, well, let's see. If you have this one, you have to think about what's happening here, because this, as you recommend, is not thread safe. What could we do? Synchronized. Yeah, it depends what you want to have. Yeah. But there's one more that we could change. If I have a lazy init, what else I could do?
Create this part of the instance.
A little bit louder, please.
We can create this part of the instance without checking.
Yeah, but some main issue. If you have to decide later, I want to create an instance, what can you do? You have the choice between implementations. So let's think about, you have an algorithm implemented that's using a lot of memory and is quite fast. And you're inside an environment, and then the memory usage is increasing, and then later you're invoking the same thing and you see, oh, I have not enough memory. Then, if you have a proxy, you can decide, okay, now I will create a different instance that is slower but is using less memory. And this is only one thing you can do with this. So the fixed decision for an implementation is not necessary. You can be more flexible. Okay, and new is the easiest one, but if you have legacy code, it could be that you have no default constructor. Or the implementation you want to create needs a little bit more complex init process. So you need a factory, a builder, whatever. So the strategy how to create this instance is fixed here. So maybe how we could combine this with a factory pattern. That's it. Okay, to make it a little bit more generic, let's say this is a basic. We want to change this one, so we would say for this creation of an instance, I will introduce an interface called service factory, and the only thing that I want to do is create an instance. This could be something. Then I want to get rid of this equals null, because maybe it's okay, my system, it doesn't matter if you have one or many of these things, but sometimes you want to have it, for example, only want to create a singleton. Then you have a service strategy factory, and this will create the real subject. So inside this method, you can decide what is the way of synchronization, and inside create instance, you can decide what would be the right implementation and how to create it. Any questions until now?
Isn't that the same thing as the other place?
No. Hopefully not. I will show you. Have it in mind, and then maybe I can give you the answer. For example, if you want to change this one, I would say this. So I've done everything on it. So to give you an answer, if you say the new operator is enough for you, fine. you can do it. Otherwise, you can create here the instance, for example, collecting these metrics or whatever. And then here you say, okay, to create this instance, it doesn't care if you have multiple instances or only one. So you can say, okay, equals null. If you say, I need a synchronized version, but the creation is the same, you can combine it, creation and the strategy, how to create. And these are two different things. Was this the answer of your question? Hopefully. Okay, good. So, let's say, how to use this? I would say I need an instance of Service Factory, and I need an instance of the Service Strategy Factory, and then I only have to combine both. So you could see from only delegating, you have Strategy Factory .real subject, and then, if necessary, create, and then invoke the original method. So this is a lot of handwritten stuff, but now you have the chance to write default creation, special creation, whatever, and different strategies, synchronized, not synchronized, whatever. So let's see how a synchronized version would be. So starting from the same point, I would say, okay, the creation is the same, only new operator in this case, and then we want to get rid of this one, so write a synchronized one. Oh, it's a synchronized one. But I can combine both, and this is important stuff. So if I'm writing this a little bit more generic, I have something like this Lego pieces, so I can put together what I need. In this moment, we are writing a lot of stuff again and again. So if you have a proxy, and it will have the same interface implemented, so you can combine proxies, and this is quite cool, because then you can say every single part of functionality is a single proxy, and you can put proxy inside proxy inside proxy inside proxy. Sometimes it makes no sense, some things, for example, here I think a remote proxy that's going on a virtual proxy and then asking a secure proxy, if it makes sense, maybe it's not what you really want, because the virtual proxy resource saving is not really active, and the same here. So you have a lot of combinations, but sometimes not useful. So you can't change the combination, you have different meanings. But if we want to see, we had the security proxy implementation and we had the virtual proxy implementation. What we have to do now, if we want to write it by hand, is we are writing a virtual proxy in the same way we have done it before, without strategy and all this stuff, only to make it easy. And then I have the original one, the last one in the line that is created. And then I have a combination, a secure virtual proxy that is working on a virtual proxy. What is the problem here? I think the biggest problem is there's hardwired proxies. Nobody wants to write all this stuff for every combination. So we have to see if we could change it in a way that we can add proxies together without writing everything. For this, we need a generic proxy. And if you have a generic proxy, as mentioned before, we have a dynamic proxy since JDK 1.3. So even you with 1.4 can use it. Yeah, you have 1.4 now. You have the next version. Okay. Oh, well. So the dynamic proxy is what you can use. So both are good or not. So the dynamic proxy itself will give you a generic implementation, but the handwritten stuff could be more effective. And later, I will give you some ideas how to make it fast if you have static compiled proxies. So how to use it? A dynamic proxy, you have to use Java lang reflect proxy. Then you have an interface and you need an implementation. That's it. If you want to use it, you have to write some basic stuff. But please, step by step. So what we want to do is we have this cast, because the dynamic proxy will give you something like object. So the last step, what we have to do is service cast. also casting to this interface. Then I will ask the proxy, please give me a new proxy instance. For this, I need a class loader to say, okay, from this class loader you will get everything you will need, because this could be a different class loader for sure. Then, if you have only one interface, or if you have more than one interface, you can decide, okay, these are the interfaces the proxy will be implementing. And then here's the important part. The invocation handler. The invocation handler is an interface you have to implement to use dynamic proxies, and the main thing is always to implement the invoke method. The invoke method will give you an object and will need some information. And here the information you will get is what method was invoked on the proxy, and then you can decide different things. So if I'm writing the normal proxy inside the invocation handler, I only say, okay, use the right implementation and delegate immediately through this implementation. So this is a dynamic proxy, but doing nothing. It's only a delegator. Okay? First line. If you're casting, or if you want to cast and you don't want to make it with try-catch blocks, use this one. Jump into this cast method and you will see there's only try-catch and all this stuff inside. I'm not sure which JDK it is, but it's in every class. I had to check, but I think it's quite long.
So it casts whatever the proxy returns to service.
Right. This is important for object to my interface. Yeah.
From the service implementation. If service implementation has some additional methods, you won't be able to access them in any way.
So this means the clear transformation from object to whatever you really want to have. So now there's one question: how to make a virtual proxy? Easier as expected. So if you have the same bootstrapping code, we say, okay, now I want to have a dynamic virtual proxy. That means this one is null. I have a service implementation, and if it is the first time invoked, I will do it. So this is more or less not thread safe as before, but we want to write this one more generic. So if I'm using dynamic proxy and doing it in this way, the main problem is that I have to do it for every interface, and this is quite useless. So let's say this service is a problem that I have to change, this one I have to change, and this one I have to change. I can get it from outside. Then this one I have to change. I have to remove it. Why? I will show you later. And this one, the original or whatever I want to invoke, the instance itself, I will get from outside. If I'm writing this one, I want to call it Proxy Generator. It's something like a factory method, and let's see what it looks like. So I write it only with generics. The green part is what I changed, and this is more or less what we are getting. So we have now a method that is Proxy Generator. I made it static, and so I can only say make proxy. I will give a subject and a real subject, so an interface and something I want to work on. So in this case I have only a delegation, but it's a functional interface. Anyone who's able to write Java 8 in production, the rest is writing Java 8 at home, huh? Yeah. So we have functional interfaces, so we can use it. So with dynamic proxies, we are writing less but more generic code, and we can create all these groups, virtual, remote, and security proxies. So, but how to combine proxies more generic? This is the main questions. And from this, we have to switch from a factory method that is static, and we need everything, to a more fine-grained stuff, and this is a builder pattern. If you want to have a builder pattern, you can combine different options. This means if I want to have a security proxy inside a security proxy, and then last version would be a virtual proxy, you have two different ways of doing it. The first one would be one security proxy with all rules and one virtual proxy, and the other one could be two security proxy, everyone with one rule, and then one virtual proxy. If you write your first proxy framework, your decision would be good if you have the second one, so that you have really one task by one proxy. If this is too slow, then you can optimize all this stuff. Okay, but for this we need a cascaded proxy and a generic cascaded proxy. Well, let's see. I have a proxy and with a child, with a child, with a child. A child must know his parents so that I can lead to the next level. And in the moment, we only cascading proxies of the same type, but all dynamic proxies. So I have no change of the interface between. So with this nested builder pattern, you can solve this one. So you have all this stuff that they are talking in both directions. Okay, so how to combine proxies. We want to add an security rules. So we have this interface, for example, security rule or whatever you want to have. So this is a functional interface, makes it easier of implementation later. So I have a list of the security rules. Okay, and then I would say for every rule, if I have n steps, I want to add the security rule. But this is only stuff around. So how to combine these proxies inside together? So a lot of code, but the most important thing is you have to get the information who's my parent or who's my child. It depends if you're building from top to bottom or from bottom to top. If I'm building proxies, my personal opinion is I'm building from bottom to top. So the last child we had, and then I need to work on this child, but the last step is set the child for the next level. That's it. If you have this one, you only can build this proxy inside, and you only have to decide, okay, now the return value, I am the return value because I'm the next level of proxies. So how this will be used, it must be easy if you're using it. This means if a developer would use it, you have this original, you have this interface you want to work on, then you say, okay, create builder with this interface on this original implementation, please add logging, and we had it a few minutes before, add metrics, add security rule, and so on. So if you're writing this, then you have the chance to give a very, very easy interface for developers to do this. The next one is the DynamicObjectAdapter. Until now, we have only proxies, and then if I have, for example, an interface with many methods, you know, if you have an implementation, you have to implement a lot of these methods. And if I want to change not only the full implementation, but only one method, I could do it with an adapter or something like this, but I could do it in a more easier way, because I don't want to write all this boilerplate code to implement a lot of useless methods, and how to decide if I want to have the original method invoked or the next one. This means we have the proxy, then we want to decide, I want to call the original method or the adapter method. If I want to have the original one, invoke the original. If I want to have the adapter one, I want to invoke the adapter. That's the main thing of a dynamic object adapter. This leads you to some useful stuff. So I don't want to write adapter with delegator because I need an instance. I have to be inside the inheritance and all this stuff. So the core concept is switching between method implementations. But the main thing is that I have to identify what was the invoked method and if I have an adapter, yes or no. to identify a method via reflection, it's not so difficult. The main thing is you have a name of a method and you have the params. And mostly this is enough to say, okay, you can use this one. Someone who want to ask something? I saw something, so no? Okay. And the rest is only hashcode equals and all this stuff. So you have a holder that you can use inside a hash map. You need it in a few minutes. So if you have a service with two methods, it's not a functional interface. So you can't work with lambda expressions. If you want to have this, you have, for example, first we have this implementation of these two methods. It's the original one. But if I want to have functional interface, I have to split. I have to split my interface in two functional interfaces. Why should I do this one? Any ideas? Yeah, fancy lambda stuff. This for sure. No, the target is a little bit far away. Someone who's no. Right, I'm building adapters based on these interfaces, and if you put a little bit steps more, then you have a type-safe generated dynamic object adapter. The original object adapter is working on object, so you can put an adapter inside. There is a method inside declared, but if you have no corresponding method in your original site because it's changed or whatever, this adapter will never called, okay, but you can't find it because it's only a class. But we will come to this point. So let's say I have adapted methods with this method identifier and the reflection instance method, and the method identifier and the object of the original adapter. Okay, then I could do something like add an adapter through my proxy or dynamic object adapter. Oh, 50 minutes, I have to speak faster. So then from this adapter I could get the class, then I can get all declared methods, fine. With this, every method, I can create this method identifier and put it through these two hash maps. So now I have an adapter, put it through this object adapter, and then he will put all the things to the hash map so that I can work on it later. This means if I want to work with this, I have this invoke method. You know, DynamicProxy will invoke every method. Inside this invoke, I can ask, okay, from this method you want to invoke, please create the method identifier. Then check if you have an adapted method. Have you an adapter for this method? If you have this, invoke this one, otherwise invoke the other one. That's it. This means that you can write an adapter without being inside the inheritance. So you can an adapter that's only declaring one method, and you can put it through. This is dynamic. So if you have this and you have something like, oh, I need a patch for this method, I will write it, I will send it to the server, he will compile it and put it to the class loader, and then a method is adapted. If this is not good, I can remove it on runtime again. With CoreJDK, you can write quite fancy stuff of dynamic reconfiguration. Okay, so if you will use it without a builder, you can add useless adapter because you have a method identifier that never will trigger it. So how to change this one? This is the biggest problem. I can't type it in this way because I need an adapter, otherwise I must be inside the inheritance. I don't want to be in the inheritance because I don't want to implement useless method, so this is object. But we can add some with methods from the builder pattern. The generic one is with A, with B, with C. So if I now using the functional interfaces from the beginning, I would add through a builder only with do method A, do method B. This is type with the functional interfaces. I'm getting out of the original interface, and then it's type safe at this point because I can only add this one. So I have this do work A with a service adapter A functional interface. And then you can add only functional interfaces that are matching through this service. So the main problem here is, let's see how to use it. You can use it if you put it through a builder, that you will say with a target, that is the interface I want to target, with the original. It could be null if you're invoking only one method, for example. Then add a functional interface to write an adapter and say, give me the proxy for this. That's it. There's one problem. Too much boring code you have to write. And if you want to have a type-safe version, it must be in a way that during compile time you want to have a break. I change the method signature, and now every adapter must be broken. Otherwise, you can't find them quite easy. So what could we change now? What we could change now is that we have this interface, and we want to split up in functional interfaces, especially, for example, this one. This means we are using annotation processing. Anyone who worked with annotation processor until now? It's part into 1.6 or so. This is a part you can't use with 1.4. Sorry for this. But with annotation processing, it's quite easy and it's well documented. You can use, for example, you can write a marker that you can mark interfaces with DynamicObjectAdapter builder. And then it's written, it's not so much to write. You have to implement an annotation processor. So what I can't show the code for the annotation processor because it's quite long stuff. But the thing is, during the compile process, you have the possibility, now I'm compiling this interface. Then you can check if this interface has this marker, build this builder or whatever. You can interact, you can create new source code and put it through the compile process. That means if you're writing this, you can put all this generic stuff there to create for every interface the split of, okay, I have method A, B, C, D, and I'm creating functional interfaces A, B, C, D for this, and then write this builder for these functional interfaces. This is completely automated. So if you're changing the method, every builder will be created new, and everything that will implement a different, I remember 10 minutes. So, okay, every compile will get you an actual version of this functional interfaces for the adapters. So old adapters will break in compile, and you can generate the whole builder stuff because it's so generic. So we got type-safe proxy builder. This is not bad. This type-safe generated dynamic object adapter will save a lot of time of finding out who's implementing the right one or is implementing not the right one. At runtime, we could change with all this stuff the proxies. If you have a chain of proxies, it's nothing else like a linked list. You can go through the third part, remove it, or put some new stuff inside. So you can, on runtime, add metrics or remove metrics and all this stuff. And this could be used, for example, if you want to build something like a dynamic dependency injection implementation, or if you want to implement some business rules that you want to hide for the standard developer in your team. If you're interested, all this stuff I've put to an open source implementation, and then you will find there some more stuff. I was writing with Heinz Kabutz a book about proxies, but until now it's only in German. We are translating it. But how to work with this you can find in his newsletter, or you can go through this GitHub repositories on GitHub. And there, for example, the proxy builder will give you the possibility of basic implementations on how to make these proxies fast if you statically compile it. So if I have an annotation processing, or during runtime, I can analyze, I have a proxy, now I have to build a static proxy. So I analyze the interface, and then I can create all this source code during runtime, compile it without round trip on the hard disk, give it to the class loader, and use it. And if you have this one, you're not using the dynamic proxy, you're using hard-coded proxies. You can debug it. You have source code. You can step in. You can save the source code if you want. And then you have no latency. But the most thing, if you're starting with proxy pattern, write the first some handwritten proxies to have a feeling what's the generic part, and then use the dynamic proxy from the JDK. And if this will lead you into performance problems, then check if you can generate these proxies at runtime. And then you have nearly no latency. But with this, I built a chain of this proxy builder you can use independently. There's no dependency, I think, only for add metrics that drop wizard dependency. And then as an example how to use it or for what you can use it, I built a dynamic dependency injection framework that is exactly doing this, add proxy with metrics and all this stuff. And if you want to have microservice, in the moment everything is a microservice, so I built the next microservice. You can see how to use it with a undertow stack. So feel free to contact me if you have questions. Or I have 5 minutes? I have 5 minutes, okay. Any questions until now? Okay. No, enough proxies, huh? Okay.
From the 4 types of proxies you presented, can you name a few more? List some?
Well, with these proxies, I could say it's only limited what you could think about. For example, add metrics is a function I want to add, because with drop wizard I want to have the percentile 95%, 50% and all this stuff, but this is not realized with or not implemented with bytecode manipulation, because with bytecode manipulation I have no clue what really is going on, and maybe the rules or the contract will disallow it because it's a secure environment. Bytecode manipulation is not allowed. Everything must be static compiled and all this stuff. So I was writing it like a proxy. That's it. But it's a metrics proxy, whatever you want to say to this. So every functionality that is generic could be part of a proxy. And this is quite cool, because then you have to implement only your business rule stuff, and all this proxy stuff is putting around it. Something like aspect-oriented programming, but with plain source code, no additional project. It's all core JDK, and if you want to have it fast, you can make it fast, definitely. For example, you can say, okay, from this I want to have only a singleton. Then you only could say add proxy singleton true, but you don't have to write a singleton, whatever. See, however it is.
So for the dynamic proxy, well, not dynamic proxy, but for just chain proxies, most of the stuff can also be achieved with chain of responsibility pattern. Now, how do you decide if you would use one rather than the other, and would you say the chain of responsibility is obsolete if you decide to write everything via proxies? Because you can basically achieve both the same things with both patterns.
You're right, but there's one thing. I'm working with a huge bunch of developers. Some developers really like pattern. This leads to a huge bunch of pattern. You can't read this code anymore. Some other developers, they want to get rid of this ugly pattern stuff. You can write everything in one method. And between this, you have a wide range of developers. But one thing I learned during all this time I'm writing Java code with different people is decide for one rule, one pattern, make it always in the same way, make it as simple as possible, and so on. So I don't want to say that this is the only way, but if you have proxies, you can use this proxy pattern for different things, and if your developer understood the proxy pattern, then he will be able to understand this quite easy. If you're changing to different pattern, it could lead to whatever. That's the only thing. It depends on the heads you have to work with.
One question.
Yes.
Is there a proxy penalty in performances?
No, never. Everything is zero. So, for example, yeah, sure, you have something that's going around. So this will use time. So with this dynamic proxy, you can write generic proxies quite easily, but you have reflection and you have an invoke method stuff. So it's additional stuff. You're losing some performance. If you have so high performance requirements, then the next step, if you're implementing this proxy, this is working well and you're reducing a lot of source code and you say, okay, this is well tested, cool, then you think about generating static proxies. Then you have only method directions and this is nearly no overhead. If this is too much, don't think about proxies. Then you have to write off-heap stuff or whatever. Okay, so it really depends on what kind of level, what's more important. But for the beginning, I would say work with this dynamic proxy. You can build a good framework from the developer side and then optimize if you really have a problem with concurrency, with whatever performance.
How do we come from dynamic proxies to generated at the runtime?
Yeah, you have different possibilities. So the first thing you can use is approach with this annotation processing. So if you have everything in your source code and then generate all the possible combinations or whatever with annotation processing. The other one is you have a generic entrance and then you will see, for example, this, this is it. You have what's this called? This project coin, I think. This asking sign if it could be null or not. So, for example, you're invoking something, and then you analyze what you want to invoke, and then on runtime you analyze via reflection and generating everything you want and caching this one. Then you have to decide if you want to write this cache down to harddisk so that you can reload it with next startup, or if you throw it away and generating every time new.
So you analyze the runtime data and change configuration?
For example, it depends what I want to achieve. So this is DynamicObjectAdapter builder I want to have during compile time, because I have a compile and then I start writing adapters because it's statically typed. But if I want to add functionality and the developer is not able to see it, or it's not necessary that he could see it, then you can do it in runtime. If runtime will give you enough time to do this, you need a few microseconds for this compiling stuff. But it really depends what goal you want to reach. You have both ways, and mostly it's easier writing first dynamic proxies, then using annotation processing, and if this is, then going to compile time at runtime. This is because from step to step it's a little bit more complicated to write it in a generic way. If you want to write Java code that is generating Java code, check the open source project Java Poet. This is a very good builder pattern for writing source code. Also to write code that is writing source code. That's it. Okay, they are nervous. I have to stop. If you have any more questions, feel free to contact me. Today I'm here. Tomorrow morning I have to leave. But you can reach me via Twitter. That's the best way, or via mail. I hope you enjoyed it a little bit and you had an imagine what you can do with your proxies. Thank you very much.